Welcome to Menace the Menace. Thank you so much, everybody, for being with us today. We have a very special episode, a return guest that we're so excited about. Dr. Hugh Ross is back with us today we get him for a whole hour, so we're going to dive into things right away. We're super excited to have you. Thank you so much for being back with us. Just a brief bio on Dr. Hugh Ross, an astrophysicist and author. Hugh Ross is founder and senior scholar of Reasons to Believe, an organization that researches and communicates how discoveries about nature harmonize with the words of the Bible. How awesome is that? His books include The Creator and the Cosmos, Why the Universe is the Way It Is, Improbable Planet, and Designed to the Core. And probably some more also. Dr. Ross, thank you again so much. You are probably the best person that we could have ever reached out to or even dreamed of having on this episode, because we are going to talk about a topic that causes a lot of division in the church these days, unnecessary division, I think. But it is a topic. It's a topic that I, kind of got sucked into myself, I don't know, maybe a year ago or so. And Ben and I always bumped heads on this. And so we enjoy talking about it. It's the flat earth topic. So thank you for being even willing to talk about this topic. Probably to you, you're like, yeah, it's not even that big of a deal. You roll your eyes at it. I don't know how you feel about it, but I know out there, because when you're on social media, you just see a lot of division, especially in the church. And it's something that we should probably address, I think we need to address, and I think we can address it here today. So we have some content that we want to share, some questions for you. For all those who are following, thank you for being with us. Please comment, share, like, subscribe. And if you have questions for Dr. Ross after today's episode, please put them in the comments or message us, and we'll try to get those questions answered. I won't be answering them, but hopefully Dr. Ross will be able to answer them. And maybe, just maybe, he'll come back for a third time and answer some questions from our viewers and our audience. Thank you again, and let's get right into it. Ben, if you could take it from here, that'd be great.
All right. So because we have an hour, okay, I've got 3 pages. I did this last time, so I haven't learned my lesson, but I've got 3 pages worth of stuff to talk about. I don't think we're going to get through all of it, but we're going to show little clips, okay, that I think summarize some of the questions that users have sent in for this episode. And just things that keep popping up while I was doing research on this topic. Because full disclosure, I'm not flat earth. Dennis was borderline until I swung him over to our round earth side. Okay. As I've learned, we're called like globies or something like that. I guess that's a derogatory name for people to believe the world's round. So anyway, I'll show clips that summarize the questions. And if you could give us your best response. I think you're the man to ask, because you're a scientist, an astrophysicist, and a pastor. So you've got the intellect to back up your answers. It's not just opinions at this point. And so if that's okay with you, we're just going to dive in. Good?
Sure. Let's see it.
All right, brother. Dennis, you want to queue up number 1?
Yes, let's do this. Here we go.
There's definitely not ready to hear this. But there is no real picture of the Earth. Every picture that's been released that's on Google and or released from NASA is a 3D render. There's only 2 pictures that Earth claims to have in its vault. Let me show you them.
You're telling me that my iPhone 3G wallpaper isn't real?
That's the blue marble. The blue marble, as known from popular media and your iPhone 3, this claims to be an actual photo of the Earth from space.
It's claiming that?
Do you want me to show you the other one? The other one's hilarious. This is the real one, apparently.
What?
It's called the pale blue dot.
Who took that?
I've taken better pictures whenever my phone is in my pocket accidentally. That's what this looks like.
Why do all these pictures look so fake?
If you go through Google, there's not a single one that looks even remotely real. There's definitely not ready.
Okay, so question 1 that a lot of people kept asking is, why are all of the photos of the Earth CGI? I didn't know that was the case. I still don't. Are you aware that that's what some flat Earth folks claim?
Yeah, I'm aware of that, and that's also used to claim that we've never been to the moon, that everything we see from the Apollo program is basically CGI. They even claiming that the James Webb Space Telescope and Hubble Space Telescope images aren't real. It's all CGI. NASA is faking us out. We've never been to the moon, and we don't have telescopes out in space taking these photos. It is true that every image is no longer a photograph taken by these amazing telescopes. We astronomers replace photographic film with charge coupled devices. And that's also in your camera. I mean, the camera in your phone, your smartphone. If you have one of these point and shoot cameras, it has a charge coupled device at the back, which is basically an array of photometers that's actually taking in the light and then computer processing it to produce the equivalent of a photographic image. So yes, computers are involved. It's not a photographic film anymore. And the reason why is charge coupled devices are far more sensitive and far more accurate in what they're able to portray. So it's way better than photographic film. And we can produce objects or images with far higher resolution, far greater color, reliability. And so it's actually superior to photographic film and actually showing us what the object really looks like. And so, yeah, it's the fact that it's computer process does not mean that it's been altered. Now, the exception to that is the James Webb Space Telescope is an infrared telescope. After all, with the Big Bang universe, the farther away you go, the farther back in the redshift, red end of the spectrum, light is shifted. And so if you want to observe the most distant objects in the universe, you want to be observing them in the infrared because that's where all the light's been redshifted, and that's why you get much greater sensitivity. Now, what the NASA people do is they take that infrared image and they shift all the wavelengths by exactly the same amount to put it into the visible part of the spectrum so we can actually see it with our eyes. Otherwise, only a computer can analyze the image. So yes, they do shift the colors, but they're all shifted by exactly the same amount so we can get the impression of the wavelength variation in the infrared. The same thing's done with our X-ray telescopes and gamma ray telescopes and radio telescopes. We're observing in a region where the naked eye is not able to detect the light, so we shift the wavelengths so that we can see them with our naked eyes.
Got it.
There's no distortion going on.
So they're not wrong in saying that the images we are seeing are CGI or they're computer enhanced or computers are involved in generating them, but it's because the way the photos were taken were in a way that our eyes wouldn't be able to perceive.
Well, that's the case for, say, the James Webb Space Telescope, because it's not in the visible part of the spectrum. And so in order for us to be able to appreciate an image, we have to shift all the wavelengths into that part of the spectrum that our eyes are able to detect. But again, everything's shifted by exactly the same amount. There is no distortion going on. And the problem is people look at CGI and they're thinking of Star Wars, where we're basically using computers to produce something that's not real. But in this case, we're using computers and charge coupled devices to actually get a more reliable and authentic image than what is possible with photographic film. And that's so you notice photographic film is not even available anymore.
Right.
Yeah, it's obsolete.
Yeah, I don't think that their accusations that the pictures of the Earth aren't on film anymore. I think they actually say we don't have a photo of the Earth from a distance away. Everything is bits and pieces that have been, I guess, coupled together or stitched together.
I noticed they showed that image of the Voyager spacecraft looking back on the Earth.
Is that the pale blue dot?
That's the pale blue dot where you're looking at the Earth from 1 billion miles away. But, for example, we have images of the Earth-Moon system from the Chinese craft. We also have them from American craft. And so I could show you images. You can see them on the NASA website that shows the Earth and the moon together at a much closer distance with better cameras than what was available in Voyager. Voyager actually was sent up in 1970. So yes, it doesn't have the same sophistication as what's on the latest spacecraft. But yeah, they were deceiving you into thinking that's the only image we have of the Earth from a distance. That's not the case.
Okay.
Again, the Apollo astronauts were photographing the Earth from the moon. And we have spacecraft that photograph both the Earth and the moon together from, like 100 million miles away.
I'm going to ask you to email me those photos, and I'm going to insert them on the back end here, so people could see the images that you are saying are real images and not just eating this up that everything's CGI. Okay.
Right.
All right.
That's a big deal.
That is a big deal.
Thank you for telling us this, because this is the first time I'm hearing of this. I was under the impression that was the case, that we didn't have, that the Earth, the pictures of the Earth we have right now are put together with pieces.
Well, the claim is based on the fact that no Apollo astronauts set foot in the moon. Everything there was faked. But as I wrote in an article I posted on reasons.org just a few weeks ago, there are laser reflectors on 3 different parts of the moon. Physicists on Earth reflect laser beams off every single day in order to test their theories of gravity. And so how did those reflectors get there? And I'm old enough to have actually watched it live, the landing of the first Apollo mission, Apollo 11. And as soon as they got out of the spacecraft, out of the Eagle, what did they do? They set up a laser reflector. Laser reflector is literally used every single day by physicists around the world. And 2 others were placed there at later missions. So it can't be a fake. Something put that stuff there.
Yeah, I think a lot of... So having been doing research on this for the past, I think, 2-3 weeks now has exhausted me. Mentally, spiritually, emotionally.
What you might enjoy is what the director of the Jet Propulsion Laboratory said in a famous speech a couple of years ago. He said, "We thought about faking it, but realized it'd be way cheaper to do it for real."
Oh, that's funny. Who's that? Parsons?
Yeah, it might have been Parsons who said that. Yeah.
Got it. Okay. That's a whole other topic there. But yeah, it's just been such a rabbit hole. I can see why people are into this so much and why they hold to it so firmly. But what a lot of it to me seems like it stems from, and granted, I get it because I'm on the same page, but on other issues, not necessarily this one on the shape of the Earth. It seems like it stems from a deep, deep distrust of the government, of NASA, of the experts. And I mean, over the past few years, we could see why people are there, right? Why they distrust these people.
Well, we can. I mean, 30 years ago, I debated the president of the Flat Earth Society on radio.
Really?
It's interesting. As soon as he found out I was an astronomer, he hung up the phone. And that was the end of the debate.
No way.
Yeah, he wouldn't participate. And, the flat Earth belief was just dead in the water until the internet became a cheap worldwide phenomena. And what people don't realize is that people make a lot of money on their internet by polarizing people. We see it in politics. We see it in this issue. We see it in religion because they figured out they can sell more product if they divide people against one another. And so, I can't think of a time in my lifetime when you had 2% of the world's population seriously believing that the world is flat. That number was 0% before the internet came about. But with the internet, that percentage has been going up. And again, it's not just people saying, wow, we've been deceived about the figure of the Earth. We've been deceived about a lot of things, and they don't appreciate that the internet, in its attempt to sell a lot of product to people, is purposely pitting people against one another.
Right.
Yeah. No, I feel dumb.
No, it's not. Okay, I used to think, to be honest, people that thought the Earth was flat, they were just dumb. Okay. Dennis, I even told you, I don't think people with any of our followers that believed in flat earth, they didn't hold like a high school diploma. I take that back. Okay. I was being facetious and rude. But from spending all this time looking into this, there's a lot of like great people that believe this stuff and they just distrust what the authorities are telling them. And their greatest authority is themselves. And so they'll look at things and be like, well, that doesn't make sense based on what they've been telling me. And then they'll start looking into things. And that's where the internet comes into play. And that's why the movement has spread so much, is because people see things differently than what they've been told. And then they look into it and you go down the rabbit hole, right?
My advice on this is actually let them discover for themselves. They don't trust what they're seeing from NASA and the government and from research scientists. It's not that hard to figure out what the shape of the Earth is. You don't need a lot of tools. Why don't you put it to the test yourself and come to your own conclusion? Forget about all those scientists and mathematicians. Do it yourself. And I think that's the way we're going to get back to the flat Earth belief being 0% instead of 2%. Although people claim it's as high as 8%.
Wow.
But I think that 8% is based on people trying to stir up controversy. In my experience, only about 2% of American adults are serious in their belief that the world is flat. The other 6% are simply trying to stir up a lot of dust. Or they're being humorous.
What do you think, when you say put it to the test, what do you think would be the easiest test that somebody could perform themselves that can prove the shape of the Earth?
Well, the belief has been that all the ancients believe that the world is flat. That's a total myth. Ancients all over the world were able to figure out for themselves that the Earth was a sphere. They were even able to figure out the approximate diameter of the Earth. They were able to figure out how far the moon was away, the sun was away. They figured out that stars were bodies like the sun. They were not dumb, mainly because they used straightforward investigation. So, for example, what you see amongst the ancients is that they would look at the shadow of the sun going down a deep well, and they notice as you traveled north and south, the shadow in the well would move up or down. And so they notice, for example, that you can see certain stars in Sudan that you can't see in Greece. And so they began to measure the distances between Greece and Sudan and what they were seeing in the sky, what they're seeing with the shadow of sunlight down a well. And they were able to use plane geometry to determine not only the shape of the Earth, but the diameter of the Earth. Another one was the obelisk effect. The ancients loved to put out these really pointy obelisks that went up 50, 200 feet in the sky. Well, they cast a shadow. And what you notice is the length of the shadow changes depending how far north or south you are. And so they used that to determine that the Earth must be a sphere. And everybody knew about the crow's nest effect, that if you see a ship in the distance, you're going to see more of the ship if you climb up the mast into the crow's nest than if you're sitting on the deck of the ship. Again, it's a plane geometry problem. If you're on a spherical body and you're looking at a faraway mountain, all you're going to see is the top of the mountain because of the spherical shape of the Earth. And so if you're looking at a high mountain 200 miles away, you're not going to see the bottom of the mountain. You're only going to see the top of the mountain. If the world was really flat, you should be able to see the bottom as well as the top. But that's not the case. And actually, even going up a few feet makes a difference. And we actually see this in the recording of Noah's flood in Genesis 8. Because you got Noah on top of the ark. He can see the distant hills. He releases a dove that flies low over the waters. And what does it say about the dove? The dove couldn't see anything except water. The dove was flying at a lower level over the water than what Noah was on top of the ark. So even a difference of 20 feet can make a huge difference into how many more miles you can see across the horizon. Now, in the 21st century, I'd say the easiest way to persuade a skeptic about the shape of the Earth, have them take a night flight from New York to Santiago, Chile. It's basically a north-south pass, and you're going over the equator. And tell them to book a window seat. and then look out the window as you fly at night from New York to Santiago, Chile. You know what you'll see as you look out the window? You'll see the constellations, the stellar constellations, slowly turn upside down as you fly from New York to Santiago. That can only happen if the Earth is a spherical body. If it's flat, you wouldn't be seeing that effect.
Has anybody taken that flight and recorded it maybe as it's happening?
Well, I've done a flight like that 3 times. And yeah, it's always a neat thing to look out the window and see, for example, the constellation of Orion. What's this, the Hunter? It's standing up in the north, and when you arrive in Australia or South Africa, it's upside down.
Okay, we've got some videos that kind of show that, not necessarily what you just described, but they're questioning, hey, why aren't the stars changing while people are in flight? So we'll get to that. Okay.
Yeah, that's good, because they really do change.
I know. Okay, let's go to the next one. Let's keep going down the line. Okay, or down the list. Here's Dennis. Hold on. Before that one, let me ask this question. This is what my friend asked me here locally that I go back and forth with all the time. On a globe, who's up and who's upside down? Okay.
Well, they're both up because they're both being drawn by Earth's gravity to the center of the Earth.
So nobody's upside down?
Nobody's upside down.
Oh, why? Because the center, it's relative. Because everybody's feet are pointing towards the center of the Earth.
Everybody's feet's pointing towards the center of the Earth because the gravity of the Earth pulls you towards the center of the Earth.
Okay, great. That's a good answer for me. I'm going to take that back to him. I don't know if it'll suffice, but that was, I just wanted to get that one out of the way. Okay, Dennis, if you want to pull up the next video we've got. And this relates to what you were saying about being on top of hills and looking out towards the horizon.
If ships sail over the curve of the Earth, why are we able to bring them back into view with high-powered lenses as if they merely sailed past the horizon of the eye's angular resolution? Why are we able to see things over long distances, which according to the formula for a ball with a circumference of 24,900 miles, should be thousands of feet below the curvature?
This photo, 700 miles away, you see in the Alps of Switzerland, from a mountain that is 3,700 feet tall, 700 miles away. That is 40 miles of curvature missing. 40 miles of curvature missing. Please explain this, Globies. Please explain this.
Ships sail over
Globies.
Yeah, that's easy to explain because you've got 2 effects going on. You got the global effect, which means that you're not seeing the bottoms of those skyscrapers.
I noticed that,
Or
yeah.
the mountain. Even from a relatively close distance, you're not able to see the bottom. But the other thing that they're ignoring is the effect of the atmosphere. The effect of the atmosphere refracts light, so it bends light around the curvature of the Earth, which is why you're able to see a mountain 700 miles away. Because you're getting a lens effect from the atmosphere of the Earth. So you actually see a little bit farther. Now, if there was no atmosphere, you wouldn't be able to see objects that far away. But the atmosphere bends light, just like water bends light. It's the prism effect. And so you need to put those 2 effects together, and if you do it correctly, you get the diameter of the Earth and the shape of the Earth.
Is there a way to test how far you'd be able to see without atmosphere?
Well, notice that the atmosphere's density and humidity changes with respect to time and location. And so the prismatic effect of the atmosphere, how it bends the light, it will change depending on the density of the atmosphere and the humidity of the atmosphere. And so by looking at different images, like for example, I was on top of Mount Baker in the northern Washington, and I was able to see all the way to Mount Rainier. But all I saw was the tip of Mount Rainier. Now, the distance there is only about 250 miles. But because the atmosphere was so thin at the top of Mount Baker, we're talking over 10,000 feet, you didn't get as much of a refraction effect as you do if you're at sea level. and so it didn't bend quite as far. And so in some places you can get as far as 700. That's about the extreme limit, to go as far as 700 miles. More typically, you're seeing 200 or 300 miles. And if you're right at the bottom where it's really dry, you may be doing well to only see 80 miles.
Wow. And so you're saying that the mountains that he showed in that photo, those mountains are a reflection off of the atmosphere?
It's refraction.
Refraction. Can you explain that?
Traveling through our atmosphere gets refracted, which means the light doesn't travel in a straight path. It bends. And because it bends, you can see farther over the horizon than if you didn't have that refraction effect. Now, a good example of that would be the moon. The moon doesn't have an atmosphere. So the Apollo astronauts on the moon quickly recognized, hey, we can't see as far over the horizon as we can on Earth. There's no refraction effect of well, the moon has a very tiny atmosphere. It's got a thin argon atmosphere, but it does very little to refract the light. You're getting the effect of the curvature of the moon being the dominant factor. It's not the dominant factor in the case of the Earth.
Okay, very interesting. And what about the ship that's further out, and then he can't see it with his eyes until he starts zooming in with that lens? Is that the same effect?
Because that lens has much higher resolution than his eyes. And so he's just zooming in and saying, oh, I can see the whole thing. Whereas with the eye, all you see is a little dot. But if you're using binoculars and zooming in, you get to see more of the image. But if that ship were a little bit farther away, guess what? You wouldn't be able to see the hull. You'd only be seeing the ship above the hull. But they picked a ship that was close enough that you could actually see the hull as well.
I wonder if there's any videos showing people zooming in and not seeing the hull.
Oh, yeah. You can find images online where all you see is the mass of a sailing ship. You can't see the hull of the ship or the people on board.
Nice fireworks.
Yeah, you can see the mast and the crow's nest, but that's it.
Okay, and so that would counter what this is saying. It's just that this ship is closer than the one where you can only see the mast.
Well, I mean, if you read the sailing literature back thousands of years, when people were shipping or when sailing in a ship, they would always put a sailor up in the crow's nest because being so high above the deck of the ship, he could see a lot farther over the horizon than people on shore. So he'd say, land ahoy. And the people would say, I can't see the land, but he can see the land because he's 40 feet higher than the rest of us. And again, that only works if the Earth is spherical.
Right. Yeah, I'm just wondering if I could find a video showing somebody zooming in with that same, because everybody keeps bringing this up. Okay, and again, I'm so deep, I'm exhausted. I'm trying to crawl out of this hole right now emotionally. Everybody keeps bringing up, we have lenses now that we can zoom in past the horizon. So they'll say, we were told that we can watch ships sail out and then go beyond the horizon over the curvature, and that's why we don't see them anymore. Now all we do is get a lens that can zoom in beyond what we thought was the horizon, and there's the ship.
Yeah, again,
sailing along.
Those people are assuming there's no refraction effect from Earth's atmosphere. That's the mistake they're making. Because of the refraction of Earth's atmosphere, you can actually see farther along the spherical shape of the Earth. For example, when you watch the sun set, you actually see the sun setting longer than you would if there was no atmosphere. Because the atmosphere of the Earth is actually bending the light of the sun around the shape of the Earth. And so you actually get to see a sunset lasting a few minutes longer than it otherwise would.
And that's the light from the sun bending around the atmosphere and around the curvature?
Well,
that's why we see it longer?
the atmosphere of the Earth basically bending the light. Again, the prism effect. If you've got a glass prism, it actually changes the path of the light. Just like as you beam light through water. I mean, have you ever tried to spearfish from above the water and you see the fish there and you shoot at it? You miss because you're not taking into effect that the water itself bends the path of the light.
Okay. And
That's a
the
great
atmosphere
example.
will do the same thing to a lesser degree.
And that refraction allows us to see something that might be beyond the curve to some degree?
Yes, to a big degree, actually.
And that's why we just see the tops of mountains and not the bottoms?
Well, if you go far enough away, even with the refraction effect, you're not going to see the bottom of the mountain. And so, again, you can go online and find images of, big, tall mountains where all you see is the top part of the mountain because you're 200 miles away, or even, in fact, I got a photo of Mount Baker that I took in Georgia Strait. And, I was a good, 80 miles away from Mount Baker. But you actually see the top of the mountain sitting on the water.
Oh, interesting.
Yeah, and again, that would only happen if you got a spherical Earth.
That makes sense. Yeah, total sense.
Interesting.
Yeah, but because of the refraction of Earth's atmosphere, you can actually see it over a larger distance than otherwise would be possible.
Okay. All right, cool. Let's go to the next one, Dennis. Video 3.
Let's do it.
Here's the video I took. As you can see, the sun is about to start rising, and it's not even past the horizon. You can see the horizon in the background, and the sun is going to start rising through that thick layer of clouds right there. Now, if the sun is 93 million miles away, it would be rising at the horizon, not in the middle of the clouds right there. So I was at about 34,000 feet when I was recording this with my P900, and I don't see how that is possible if the sun is 93 million miles away.
So in that one, and I've seen many videos like this, and I've seen one with the moon as well, where they'll make the argument that both of these balls of light are local, and that's how you can explain that, or that's how they can explain that they rise and set within the clouds themselves rather than beyond the horizon.
Yeah, they're missing two things. Number one, the refraction effect of Earth's atmosphere explains why you actually see the sun apparently below the horizon of the atmosphere. But they're also thinking that we have no way to independently determine the distance to the sun and the moon. And that's easy to do with triangulation. I mean, have you ever watched these engineers on the street trying to measure the height of your house?
Yeah.
They're basically using what the Greeks developed, plane geometry, where you know the base of the triangle, you know the angles of both sides of the triangle. That gives you the distance to the vertex. The ancients were routinely doing that, and that's how they were able to determine that the sun was much more distant from us than the moon, and actually were able to approximately calculate how far away the sun was and how far away the moon was. And so it's not just a few thousand miles away, it really is 93 million miles away.
And you're saying that, again, because of the refraction, that's why it looks like the ball of light?
That's the way it does. And the refraction effect is going to be most intense at sunset and sunrise, or moonset and moonrise.
Interesting.
Yeah.
So
once the moon and sun rises up, the refraction effect becomes less because you're looking through less of the atmosphere. When you're looking right at sunset or sunrise, you're looking through the thickest part of the atmosphere where you get the greatest refraction effect. Wow. So the fact that the refraction effect changes as the sun rises from, say, at the horizon to 10 degrees, to 20 degrees, to 30 degrees, you can actually determine the lessening of the refraction effect.
Wow. Yeah, I think it was stuff like this that really made me more sympathetic, because when you see things like this, you're like, hey, hold on a second. How are there clouds behind the sun? How are there clouds behind the moon? And then you see videos like this once you look that up, and you see a bunch of videos like this. So again, to me, it boils down to people not believing what they're told because their eyes are seeing something totally contrary to what they've been told. Right.
But I'm also recognizing that a lot of adult Americans have forgotten their high school plane geometry.
Totally.
And so if you go back to your geometry classes, you realize, no, we got a very rigorous way that's not subjective. It's a direct distance measuring method, which
Right.
means it's indisputable. And we use that method to measure the distances to stars, to galaxies, and of course to the sun and the moon. And that technique allows us to get very precise measurements. I was mentioning earlier how every day we got physicists sending a laser beam to that lunar reflector and having it come back, and they measure the time.
Mhm.
And so knowing the velocity of light, they can measure at a very high precision the distance between Earth and the moon. And what they're actually trying to determine is how fast is the moon spiraling away from the Earth. And it's moving away from the Earth by about 3.5 centimeters every year. And so they're able to determine that with high precision by, again, bouncing a laser beam off those 3 reflectors that the Apollo astronauts put on the moon.
Where's it moving to? Where's it going?
Well,
that's a strange thing for me.
The moon formed as a result of 2 rocky planets merging together. So it was Theia and the proto-Earth, and they collided with one another, made the Earth bigger and denser. There was a debris cloud that condensed and formed the moon. So if you were to go back, say, 4.5 billion years ago, the moon and the Earth were very close together. But dynamically, the moon was spiraling away from the Earth. And so the moon today is much more distant from the Earth than it was, say, 4 billion years ago. And actually, the rate of recession of the moon from the Earth plays a crucial role in whether or not advanced life is possible on the Earth. We owe our existence, we owe this show to the recession of the moon from the Earth, and now we can measure that to extremely high precision.
We'll probably have to do an in-depth discussion one of these days on the age of the Earth, the new Earth versus old Earth, creation, all that, because most evangelicals, right, are probably like, oh, he's talking about billions of years, I'm out. The second those words come out of your mouth, 80% of the church is going to be like, oh, I see what this guy's doing. People are going to say you're a NASA shill. You're talking about the Great Deception. Point. You know what I'm saying? So we should definitely, and this is what I'm talking about. A lot of these, it all comes down to they don't have faith in the institutions and the words coming out of the mouths, especially of the experts.
Yeah, and they're not looking at the numbers either. I mean, what's interesting is a couple of days from now, I'm going to be dialoguing with a young Earth creationist professor at a Christian university.
Oh, cool.
He has a young Earth view. I have an old Earth view. But I'm going to be explaining how, we're both young universe creationists, because there was a debate in the early part of the 20th century. Is the universe quadrillions of years old enough that we got a basis for believing that maybe Darwinian evolution can happen naturalistically, or is the universe only billions of years old? The debate ran for about a 40-year period. The young universe astronomers won. It's only billions of years old, and that's way too little time to sustain a naturalistic evolutionary theory of the origin and history of life. And I found that that's mainly the big concern of young Earth creationists in the church. They're worried if they give the scientists enough time, then we don't need God to explain the origin and history of life. And my point is, the fellow I'm going to be dialoguing with, we only differ by a factor of 1 million. That's only 6 zeros. The atheists differ with both of us by many, many more zeros.
Right.
So why should we let a factor of 1 million get between Christian fellowship? We're both young universe astronomers.
Yeah, and neither position is trying to take away from the fact that God made it.
Right.
Neither position does that. It's literally just a matter of the first few chapters of Genesis and how you want to, actually maybe the first 2 or 3, right? And how you want to interpret it. That's all it comes down to. Everything else in the Bible kind of stays the same for both sides.
Yeah, I found if I can get the non-Christian skeptic past the first 11 chapters of the Bible, the rest of it is pretty easy.
Cake.
Yeah, they can take it and they can give their lives to Jesus Christ. It's actually why I wrote this book. This just got released literally 2 weeks ago.
Nice.
a scientific,
congratulations.
which I actually address these issues. And I actually make the point that, if you really believe in biblical inerrancy, you can't defend biblical inerrancy from a young earth perspective. It actually forces different Bible texts to contradict one another. Only from an old earth perspective can you read all the creation texts literally and consistently.
Wow.
And hopefully that'll no longer be a barrier to people coming to faith in Christ.
That's quite the claim. We're going to have to come back to that one. All right. I'm going to get that book. I'll read it and we'll discuss it.
That'd be great. Yeah.
Yeah, I'd love to.
Idea. We can add that link to this episode.
Definitely. I'm really interested in that one. I'm still working through my, what is it? What's the Genesis one that you have?
Navigating Genesis.
I almost said Answers in Genesis, and I'm like, that's not the one. Okay, let's hop in the next one, Dennis, real quick. Video 4.
Let's go.
Flight that should be a simple 11-hour shot across the Indian Ocean is from Johannesburg, South Africa to Perth, Australia. However, this flight takes a detour north, stopping in either Dubai, Hong Kong, or Malaysia to refuel, for a total flight time averaging over 18 hours. This ridiculously wayward detour is frustrating to say the least, but on the flat Earth map starts to make sense.
This is a time lapse of a flight flying from the northern hemisphere a quarter of the way around the Earth. Why don't the stars rise up into the sky as the plane dives over the curve of the Earth? If the Earth was curved, it would look like this animation. You would see the stars rising up from the horizon as they rotate due to the rotation of the stars.
Okay, so I guess we have two questions there. One is, why do certain flights take or make abnormal stops, which seem to contradict logic? Why would you go up, then down, then over, and then to your destination rather than straight to your destination? Unless you look at it from one of those overhead flat Earth maps that they pass around, then it looks like a direct line.
Yeah, you're getting a selection effect and you're forgetting about the economics. Airlines are trying to make money. Mm-hmm. And so they want to get as many passengers to the locations they got, and they want to do it in the most direct way. So, for example, if I take a flight from Los Angeles to, the Persian Gulf, my flight's going to take me virtually over the North Pole. It doesn't go straight. So from a flat Earth perspective, why are the pilots taking me over the North Pole, given that the straight line path from a flat Earth perspective would say, save the fuel.
Right.
Well, it turns out on a spherical Earth, the shortest distance between, say, Qatar and Los Angeles is a flight path that takes you over the North Pole. Or, if I were to go from, say, Los Angeles to Paris, I'm going to be flying over Greenland and Iceland because that's actually the shortest flight. Now, it's not the shortest flight of the Earth is flat, but it is the shortest flight if the Earth is a sphere. And so these airlines want to save fuel. And so they quickly figure out, okay, this is the way we can make the most money. But the example you saw there is, if you fly from South Africa to Australia, you're going to have problems getting enough passengers. I mean, you got Johannesburg and Perth, but how many people want to fly from Johannesburg and Perth? And so it's like what happens here in the U.S. I mean, for example, tomorrow I'm going to be flying to Virginia. But guess what? They're going to fly me to a hub, and then they're going to fly me to Virginia. So I'm going to be doing a path like this.
Right.
The airlines have figured if we move everybody to a hub and have them change flights, we make more money. Yes, we're flying our planes a greater distance, but how many people want to go from Los Angeles to Roanoke? That's where I'm flying to tomorrow.
Right.
Roanoke is a small city, and so you don't have the passenger traffic to justify taking a plane of people over there. You're going to fly into a hub, have them switch planes, put them on a smaller plane. So, for example, I'm going to be going on a much smaller plane when I go from Atlanta to Roanoke. So,
I never thought of this.
Taking into account the economics, you can see why they take the flight paths that they do. but the flight paths actually demonstrate proof that the world must be a sphere, because the airlines are not going to waste fuel.
That's a really good point. And Dennis, this is why I kept saying there's reasons for these things. Like everything that you've brought up to me, everything that we're bringing up to Dr. Ross, there's reasons that make sense. Once somebody actually explains it to you, rather than just shows you a little clip and is like, why would they do this? If it was round, it makes more sense that they would go like this, or if it was flat, then it explains what it's doing.
Well, I was also amused by the image they showed of the Milky Way and saying, hey, if it's flat, it'd be going up like this. No, it wouldn't. It would be turning. And if you actually looked at their video clip, you could actually see the turning of the stellar constellations.
Oh, is that because of the way that they're flying around the globe?
Yeah, as you go north to south, you're going to see the stellar constellations turn upside down. And in the video clip they showed, you could actually see part of that effect going on. I found it ironic that the very video clip they showed us is proof that the world is a spherical body. Now, let me add one more thing. You know those 3 reflectors on the moon? There are different points along the moon. Guess what? It takes longer for the laser beam to reflect off one reflector on the moon than it does the other 2, because they're positioned at different spots on the moon. If the moon was a flat body, then we would expect that you would get the same return time on all 3 reflectors. You don't. So the moon being spherical, you actually get a different time path for light to travel from one reflector to the other than you do on the other reflectors. And that, again, is proof. Not only is the Earth a spherical body, the moon is a spherical body as well.
Would it matter if that example they showed where they're flying in a certain direction and the constellations or the stars, I guess, like barely move? Because in that one, it shows a little bit of change versus that 3D animation he shows where it looks like it should change a lot more. Does it matter if you're going north to south or if you're going east to west?
No, that does make a difference. I mean, so you'll see a different effect if you're not going directly north-south. But so, for example, I see a different effect when I go from New York to Australia than I would from New York to Santiago. But you will still see Orion, for example, turn upside down, even if you're going at an angle as opposed to straight north-south.
Okay.
So, yeah.
Okay, cool. Well, Dennis, anything you had on that? Because I know the flight maps thing was a big one for you.
Yeah, the hubs just destroyed it. When he said the hubs and the money behind it, once I heard about the money, I was like, okay, yeah, I totally believe that. You know, money's involved.
Economics rules.
Yeah, for sure.
Totally.
So that was enough. Ben, you could have
physics
figured that out
as well. I mean, I run into a lot of people that are pushing the flat Earth idea, and I say, well, do you believe that the stars are flat? Do you believe that the planets are flat? The moon is flat? And they quickly recognize, to be consistent, I got to believe that they're all flat disks.
Right.
The problem with that is gravity will force the shape of any object into a sphere if the object is big enough. So notice that all the planets look like circular bodies when you take a 2D image.
Right.
But when you look at an asteroid, not the case. The asteroid is small enough that gravity does not have the power to force the asteroidal shape into a sphere. So any body that's bigger than about, say, 600 miles in diameter will be spherical in the sky.
Wow.
The force of gravity will simply push it into a sphere.
That's a really interesting point.
You don't want to know what I think angels are, Dr. Russ.
No. We don't have time.
We're not going in there. We
don't have time. No. That's a whole other rabbit hole. Dennis, stop getting me down these paths, okay?
Well, I'll give you another one. One I've heard is people said, my favorite refutation of the flat Earth hypothesis, if the world were really flat, cats would have knocked everything off the edge long ago.
Oh, geez.
That's 100% true.
Yeah, exactly. Well, that's it. Signed, sealed, delivered. Let's finish the pod now. But, okay, hey, we've got 2 more videos, okay? And I think we've got another
11 minutes.
Oh, my
11
goodness.
minutes. We're taking all of it.
Dude, I'm not even going to get to the Bible stuff.
Dude, what do you want to do? Do you want to go to the Bible stuff, or do you want to...
No, because I'm not going to do that justice in 10 minutes either.
Okay.
Part 2, coming soon. Let's just finish this. Okay, next video, number 5, Dennis.
Let's do it.
But listen, these answers are what we need. you know, we can't rush this because
Right.
the answers are so important. This is what we're looking for. We're looking for
Right.
answers, right?
Very well said. All right, here we go.
Number 5.
Why is it that even though the Earth spins at 1,000 miles an hour at the equator, goes around the sun at 66,000 miles per hour, which travels through the universe at 500,000 miles per hour, which is expanding at over 1,000,000 miles per hour, are we able to take a picture of the sky on the same day every year and never see changes in the stars, even for thousands of years?
So that's a question. I actually never knew that the claim is not only is the sun moving, the earth moving, I didn't know we're like spiraling through space, projecting forward. I didn't know all of that. Okay. So even to me, this came as a shock even to me. And so I can see why somebody can ask the question, hey, if everything is moving, not just the earth, not just the sun, not just if everything's spiraling around at 1,000,000 miles an hour or whatever he said through space, why aren't or why do we still see the same stars for the past several thousand years or as long as we can look back? Why aren't those stars out of place?
Yeah, just to be clear to your audience, I've never seen these video clips before, so I'm responding to them off the cuff. But as an
You're doing a great
astronomer, I
job.
can
Yeah,
tell
I
you
was going to say you're doing a great job.
is that the stars really do change positions as we look at them at different times through our telescopes, but the changes are tiny because of how far away those stars are. And so as the Earth orbits about the sun, we're actually looking at these stars at a different angle at some parts of the orbit about the sun than we are the other. And so we're able to use those angles to actually determine the distances to the stars. And with long baseline radio interferometry, we can even extend that out to galaxies as far away as 470 million light years. But with the naked eye, you can't see the effect. The effect is just too tiny to see. But with a telescope, you can actually see the change. And to give you an idea of how tiny that change is, even for the nearest stars, the change in the sky is like a 1 arc second, and that would be 1/3600th of a degree. So to give you an idea, the moon is about 30 arc minutes across. And so we're seeing something that's 1/1800th of that angular change.
Hmm.
And that's just because of how far away these objects are. But we can clearly and accurately measure them through our telescopes, even to a degree that we can determine with precision the distance of radio galaxies hundreds of millions of light years away.
So things are changing, but they're so far away that even though we're blasting through space or whatnot, they're so far away that we can't notice the change ourselves with our own naked eye.
Well, that goes back to ancient cosmology. The Greeks and the Egyptians and the Assyrians were trying to determine the distances to stars. And so they're looking for the parallax effect, the fact that at one part of the orbit about the sun, we'd be looking at the stars from a different angle than another part. They couldn't see the angular difference. And that's why they concluded that the stars had to be extremely distant, because they couldn't see it with the naked eye. Now, as soon as a telescope was invented, they were able to see the effect. And now that we got very powerful telescopes, we can take that effect out literally to hundreds of millions of light years. But yeah, you're not going to see with the naked eye, but it's quite noticeable through a telescope.
How
And
far?
that's how astronomers determine the distances to stars and galaxies. It's all based on that method, that fundamental method.
How far away is the closest star to us, I guess, outside of the sun?
4.2 light years. And yeah, there the effect, the parallax effect is actually bigger than an arc second, but still not detectable with a naked eye.
Got it. Okay, so it's literally...
It's about 1 arc second.
So the answer to this guy's question here is that things are so far away that the amount of motion that we're in makes no difference to the naked eye.
To the naked eye, it doesn't.
Got it.
Matter of fact, we astronomers actually look at spiral galaxies where there's major radio sources in those galaxies. And these are sources that are orbiting about the center of the galaxy. And there we're talking at an orbital period that measures about 250 million years.
Oh, wow.
But they look at it over, say, a 40-year period, and they notice that the maser is moved. And so we can actually see that movement, and we can use that movement to determine the distance to that galaxy.
See, and this is why I give more grace now to the flat earth folk, because they're just looking at things and trying to come to a conclusion with the naked eye. Whereas you guys, astronomers and people that have answers to these questions, they've got the instruments and the technology to be able to give you reasons for why you're seeing and perceiving things the way you are.
Well,
See
that's
what I'm
what I
saying?
appreciated about the ancient astronomers. When they saw phenomena that looked mystifying or paradoxical, they would say, why? What are we missing? What are we not understanding?
Right.
And that's what these flat earth proponents need to do, is say, hey, are we looking at this from just one factor? Maybe there's a second factor affecting the image that we see. Maybe there's three factors, and that's how science progresses.
Yeah, I don't think I've seen one person in all the content I've been watching, again, exhausted. I don't think I've seen one person actually pull out like a telescope and start doing any kind of calculations or anything like that. It's always been just what they're perceiving doesn't add up with what they've been told. And so then come the theories. You see what I'm saying?
I tell people, if you really want to know what's going on, look at the peer-reviewed scientific literature. That literature purposely fosters vigorous debate. And so these scientists are trying to speculate about, hey, have you thought about this? Maybe this could work. And so they debate one another vigorously. What you notice as you go through the peer-reviewed scientific literature, there is no scientist there saying, hey, this is evidence for a flat Earth. There's zero papers of that nature.
Right.
So that tells you there can't be scientific credibility to the claim. If there was any credibility, somebody would have published it. I mean, that's how you get a Nobel Prize, right? By proving everybody else is wrong.
Well, they say it's hidden. They say it's being censored. They say there's hidden documents that have been leaked from NASA and the Pentagon where somebody mentioned something about the Earth being flat. So it's always just this covert, behind the scenes attempt at deluding humanity.
Well, that's the thing about the peer-reviewed scientific literature. The papers are public. Anyone can read the abstract of any research paper for free. And in many cases, the paper is available. And it's always available if you're willing to pay a little bit of money, usually $20, $30. You can read the paper. So nothing is hidden. It's all out there. And you can actually see the debate that's going on. If something's not being debated, you realize there's no credibility to the claim.
Right. Okay, let me ask you. Okay, we've got
left.
2 minutes. Then just let me ask you this question. This was something from one of our followers that wanted to know, why doesn't our atmosphere fill the vacuum of space if there's no container over the Earth?
Well, the Earth's gravity is able to keep the heavier components of our atmosphere attached to the Earth. So, for example, methane that cows, breathe out, that escapes to outer space because the Earth's gravity is not strong enough to retain the methane, but is able to keep the water. So we keep the water, we keep the carbon dioxide, we keep the oxygen, because those have a molecular weight that's able to be retained by Earth's gravity. We keep argon, but we don't keep hydrogen. There's hydrogen that just escapes to outer space. Helium escapes to outer space. You've all seen what happens to a helium balloon, right? It just rises. And when it bursts, what happens to the helium? It dissipates to interplanetary space because Earth's gravity is not strong enough to retain helium in the atmosphere.
So the helium from the balloon just goes out into space?
Yeah.
As like a helium bubble or pocket or something, just floats off eternally, I guess?
Well, I mean, again, Earth's gravity cannot retain the helium, so it just dissipates to interplanetary space. That happens to hydrogen as well. But
so we're
stuff
polluting
that's heavier,
space.
Our gravity is able to keep it.
We're polluting space.
It explains why you see a lot of hydrogen and helium in Jupiter and Saturn's atmospheres, because there you got bodies with a much more powerful force of gravity.
Wow,
And
that makes sense.
Yeah.
That was pretty fascinating.
Cool. I mean, the very, very last one was going to be about gravity, because the last point these guys come up with, or they make, is that gravity's never been proven. It's still a theory. Nobody can explain what it is. So when you give them the answer of like, oh, gravity's doing it, or gravity's a component in what's happening, they'll say, we don't even know what gravity is. We don't believe that.
Well, we don't understand everything about gravity. For example, I don't think we're ever going to find the particles that are behind the gravitational force. But notice we have gravity wave telescopes around the world that have detected gravity waves. Those gravity waves wouldn't be there if gravity was fictitious. So, and we can see the effects of gravity all over the universe. And I just put an article up at reasons.org where I explain that we astronomers have measured the gravitational force constant to better than 15 places of the decimal all over the universe, different stars, galaxies, basically proving what the Bible said thousands of years ago. The laws of physics are immutable. They don't change. They're the same everywhere in the universe. And life would not be possible if it wasn't for the four fundamental forces of physics. To have life, you need gravity, you need electromagnetism, you need the weak nuclear force, the strong nuclear force, and they all have to be at very precisely fine-tuned values. No gravity, we wouldn't be having this podcast. We wouldn't exist.
Right.
I love that. What a way to end this. Oh man, I totally lost my train of thought.
You don't believe in flat Earth anymore. That's where you're at.
Well, yeah, definitely. Yeah, thank you so much. And where can we? I think that this was the quickest hour of my life. I mean, it felt like 15 minutes. So thank you so much. It was super informative. We'd love to have you again. You can be a resident guest if you'd like with us.
Our resident brain.
Yes, our resident brain. That's right. Where can people find you before we let you go, Dr. Ross?
Well, the website is reasons.org, and they can get free chapters of about 8 of my 22 books at reasons.org/Ross. And I put out a blog every 2 weeks called Today's New Reason to Believe, and that's free to everybody.
Awesome. And your latest book again is called?
Latest book is this one, Rescuing Inerrancy, a Scientific Defense, Why the Bible is the Inspired Inerrant Word of God, cover to cover, including the table of contents. I'm joking about the last one. So.
Is that on audio by any chance?
It's going to come out as an audio book,
Great,
but it's already available in print and also as an ebook.
Okay,
great,
very great, awesome. Thank you so much,
Thanks
Dr.
again.
Ross. You are just a wealth of information and knowledge, and we will be praying for you. And I'm sure Ben will be reaching out soon again to invite you back, and so we can finish some more.
We haven't hit any of the Bible verses.
Okay, yeah,
because that's the other side of this coin, is that this is it's a movement. Ooh. Oh no, did he freeze?
Oh, no, he froze.
Wait. No, come back. I know we're over time. Dang, he froze.
Oh, we just lost you. Dr. Ross. We'll look that up though. We'll find that article on his website. Thank you, Dr. Ross.
Yeah,
if you can still hear us.
He's still stuck.
He's still stuck there.
I don't even know if I can do anything about it.
But thank you so much. Maybe it was rapture. Maybe he's gone.
Bro, why are we here?
Why are we here?
Is it because we're not flat earthers? Actually, no. Then he would be left too. You see what I'm saying?
That's right.
Well, bummer. Okay, hey, real quick, Dennis, I'm gonna end this to save this just in case something happens with him getting kicked off. And then I'm gonna start a new recording and let's get back in.
Perfect. Oh my goodness, how amazing was that?
Dude. An hour is not enough. You can't.
What a beast in the astrophysicist. I just want to say astrophysicist all day because I'm getting better.
You're doing really good. Congrats.
I'm proud of myself, yes. I think he's going to come back. I think he enjoys talking to us.
I think he's our friend.
I think he is too. And I think if you start a chapter in Boise, reasons
to believe chapter.
Yes,
dude, I'm totally going to try to
which
do
I think you're going to do because you are such a nerd.
I'm so deep.
And
Go on.
but you're
Go
smart.
on with the compliments.
You like it too. You enjoy that. Oh my goodness. He destroyed every angle that I had in my mind for flat Earth. I still don't trust NASA.
Neither do I.
I still don't trust some of this stuff.
Neither do I, bro.
But you know what I thought of? Can I share this really quick?
Yeah.
What I thought of during the interview. I thought, fear distorts the way we view things. And I thought the fear of evil, right, in our life, this is an easy one to look at, how it just distorts the way we, the fear of the future, right, the fear of not having money, all this stuff, and it distorts the way we look at reality. But also the fear of not being deceived. Or the fear of being deceived, right? If you look at it from my point of view of why I even thought flat Earth was an option, it was two reasons. Number one, the word firmament, which you destroyed for me. Thank you very much. And the fear that we're being deceived by these governmental programs, right, and institutions. I'm so positive about that, and I still am in certain ways. But it distorted my reality of thinking of, just these provable ideas, right? Like the Earth is spherical, and things are billions of miles away, right? It's because I don't know so much or enough, and I have this fear, this unhealthy fear, really, that, they're all lying to us, so no matter what. So I try to, because of that, I want to cope with my own fear is I go and I search the internet, right? And I find the people that agree with me or prove my little, question point right. And then I give you shit about it all day.
And I just take it.
Just take it. But yeah, I thought like just that, the idea of fear and how it's being, we are manipulated. I think like the devil like laughs at us and not just that we're fearful or we're distorted on something, or we even think that the truth is a lie. Right? I mean, imagine that. He's like, oh my gosh, you guys are so dumb. You think the truth is a lie. And then he uses that to divide us.
Yeah, man. It's, listen, we got to look at this twofold, right? There's a lot of Christians that believe the earth is flat. There's a lot of non-Christians that believe the earth is flat.
Right.
We didn't even touch on the Christian reasons people believe the earth is flat. I just aggregated 5 videos. I didn't even get to the gravity one, but at least we touched on it for a couple minutes at the end. I just aggregated 5 videos that were to some degree on repeat in every single channel, every single page, every single blog, everything that I've been looking into for the past 2-3 weeks. These are some of the points that have been on repeat across all those avenues, right? And so that's why I picked these. There's others that like I actually really want answered because I'm like, that's interesting, right? But what I've learned is these guys, and when I say these guys, I mean smart people, right? Who don't believe the earth is flat. They have answers to your questions. Right. So things that they tell you, which are like, oh, no, that's not what I see. You know what I'm saying?
Yeah.
They have an answer for that. They're not just out there. Somebody's like, what am I going to lie about today? You know what I mean? That's not what's going on right now. Things can look different to our eyes than what the explanation can be. For sure.
And that makes sense to me. And I think that I can swallow way easier, right? Than some of this. I mean, I guess even more than the stuff that I just can't understand, even if he explains it to me because I'm not that bright. But, oh man,
I'll give you an example. Like again, we didn't get to the Christian stuff, so this doesn't even have anything to do with Christianity. You know what I'm saying? The stuff we've talked about so far has nothing to do with Christianity.
Right.
But even like from a Christian perspective, people that saw Jesus rise, walked around after his resurrection and then bounced back to heaven. People saw that. All right. There was a group of people that saw that.
Right.
Those people went and told others, hey, we saw Jesus rise.
Right.
And everybody else was like, no, you didn't. We've never seen anybody rise. There can be truths that you will never perceive with your own eyes. Okay. It doesn't mean that the truth isn't real.
Yeah.
Okay. And it's the same thing with this. Your eyes or your experience can tell you something, or you can interpret it some way or understand something some way, right? Just based on what you see and what your experience is. And then somebody comes along the way and is like, it's actually this, even though you can't perceive it that way because your eyes are showing you something based on something else that's happening. You see what I'm saying?
Yeah.
So it's not like a deception. It's a limitation of perspective, right?
Yeah.
But then when you start doing math or you create tools that give you deeper, further, crazier perception, like a telescope, right? Then you're like, oh, okay, I can explain why people are seeing things a certain way here on Earth, even though this machine allows me to see way further and I can make calculations on whatever's going on out there.
Right.
So it's just a matter of perspective. So seeing is not necessarily believing, in my opinion, anymore.
Can I ask you a question? Does it bother you? Let me say I didn't even give you a chance to answer. Does it bother you that they don't know what gravity is?
No, not at all. They do know what gravity is. They just don't know precisely what it is because we're limited to the third dimension. I think gravity is probably something that works interdimensionally. I think gravity might be the result of something in the fourth dimension.
I would think the opposite of that.
Okay, hold on. I think gravity might be the result of something happening in the fourth dimension that has an effect on the third. I think that's actually what gravity might be. That's why they say, it can be a particle. It can be a wave. He said we might never be able to actually find the particle that make up gravity because they don't know what it is. But what they can do is they can calculate its effect, right? So the same way we can't, for example, and it's not the best example, the same way we can't show you God's grace, we can definitely see its effects in our life.
Ooh,
you see what I'm saying?
Ben.
Was it?
I'm not that impressed with that. That was quite beautiful. Gravity and grace. And they both start with G.
Look at that.
Man,
GG.
I am super impressed. I'm going to write a song about that.
Gravity and grace?
No one's going to listen to it.
Your grace is like gravity, pulls me on down.
Look at that. It's done. The song's done.
That's it.
That's going to be our new intro for.
No, I'm just saying, and it's not a great example because non-Christians are like, what the heck is grace? You know, but for Christians, they'll get it. But I think there's things that we can feel the effects of them or experience the effects of them without without being able to put our finger on it and be like, here it is. Look at this.
Well, it's like wind, right?
Yeah, but they can show you wind. You know, they can show you what it is. It's just air. And then what's air, they'll show you what particles are in there, blah, 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 blah.
Yeah, true.
You know, but gravity itself is something that
bad example. Oh my gosh. Okay.
I'm going to write a song about that. Gravity's like wind and you can't ever see it.
Terrible song.
Terrible. Anyway, bro, what was your question?
Did it bother you that does it bother you that they don't know what gravity is? That was the question.
No.
You said
no. I mean, I think they have theories about like gravitons, stuff like that. A lot of this stuff's going to be theoretical, you know? And theories don't bother me. You don't have to mute yourself.
You can see it.
Yeah.
Mute. Oh, are you serious?
Yeah.
The entire time?
A bunch of times I was going to be like, dude, you're muted. But then I realized you're doing it because of your dog.
Yes.
It's okay. It's okay. Yeah, there you go.
Dog.
What was your greatest takeaway?
You're going to laugh. It was the flight path thing. When he said the hubs, I was like, oh my goodness, are you serious? Like, how did I not see that? Like,
that it only makes sense that airplanes will go to airport hubs.
Yeah.
Like that's what LAX is.
Yeah.
That's what the one in New York is.
It's so obvious.
That's what the one in London is. That's what, like, there's particular hubs where most flights will go into to pick up more passengers.
Yeah, it makes so much sense.
To take them to smaller destinations, right?
Yeah, they don't care about time.
And that's another thing I noticed when looking into this a ton. I looked into a bunch of those map videos, okay? Because that's a big proof for a lot of these guys is like,
Right.
check it out.
That was a big one for me. Yeah.
I know, as I remember. On a flat Earth, these guys are flying straight, but on a globe, they're making all these random stops all over the place.
Yeah.
What they're not showing you is the thousands of flights happening every single day that aren't flying straight on their little map. They've picked a few selective ones that are stopping in hubs, and that's why they'll primarily go out of like South Africa, because those keep going to hubs because the population is so small. And then from that hub, they'll pick something a little bit further north or a stop north, and then it looks like a straight line on their map. Okay, but there's a ton that aren't doing a straight line on their flat Earth map. It's going.
I just want to make sure that there are actual hubs there where they're going over.
Look it up.
I'm going to look that up.
I'm so done.
If they're not, if they're not stopping at a hub, then we're gonna have to bring Ross back for that one.
What do you mean if they're not stopping at a hub?
Well, if they're gonna go out of their way.
All of those are actual stops. The examples I've shown you, or the video we played.
Yeah.
Every single one of those is a stop.
Okay.
And then there's another video that I almost showed, but it's too similar and we didn't have enough time. There's another video where he's like, check out all these random emergency stops they make that are completely out of the way per their final destination.
That to me is dumb.
Well, it's the same thing. They stop at the hubs because that's the direction they're flying.
Yeah, it is the same thing.
You know what I'm saying?
Yeah. That's just like a dumb reason in my opinion. But that would actually, if I saw that video, I probably would have been like, oh, well, that's what they're doing on the other video also.
Yeah. I think one that I would want to see, I need to see experiments. Okay. Just because love Dr. Ross, respect them, appreciate the answers. They help a lot. I need to see it.
I want to see this.
I want to see when somebody says that, oh, it's refraction. It's light bending around. This is how I understood it. I should have asked him to go deeper into refraction and explain it, but we didn't have time. Okay.
Right.
But we see light, right?
Yes.
Everything we see, the only reason we see it is because light is reflecting off of it.
Right.
My camera, I see because of the light. The earth outside, I see because of sunlight refract. Everything is just our eyes being hit with light, and then our brain interprets it, right?
Right.
So if there's light hitting an object 700 miles away, like a mountain range 700 miles away, okay, that light is coming around the earth because our atmosphere is bending the light. It's coming around the earth. And so you're able to see what's even beyond the curve. Even though it's not on the horizon, it's beyond the horizon. It's bent. So that's kind of how I was understanding what he was saying. I don't know if that's really how it works.
Yeah.
But because we only see light, you're not actually seeing the mountains. You're not actually seeing 700 miles away. You're seeing the light that's
carrying that image
over,
almost, right? Yeah.
Yeah.
It's carrying the colors from that or whatever it's carrying, but it's carrying it over to us.
Yeah.
And so what we're looking at is not the actual one. It is the actual, but it's a bent image of it. It's actually further away than what we're seeing it.
Exactly. That's exactly right. You're not seeing 700 miles away.
Right.
If you were seeing 700 miles away, like he said, you wouldn't just see the peaks. You would see the whole thing. You'd see the base, and you never see the bases in any of those videos, right? So you're just seeing like a reflection off the light and atmosphere being bent, blah, 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 blah. Is that how you understood it?
Yeah, that's how I understood it. And it was interesting how he said that when he was out somewhere and he saw the mountain peak above the water.
Like it's hovering over the water? Yeah.
That was
even though you know it's not over water.
Exactly.
It's just how the light is bending over. It's putting that image. It's almost like a mirror effect.
Yeah.
Okay. If I took a mirror right here, I hope you don't see that I'm not wearing pants. Okay. What do you see right now? Do you see this?
Hang on. I gotta make you bigger on my end because.
Do you see this black thing right here?
The phone.
Yeah, but do you see the reflection in the phone?
Yeah.
Do you see this thing on my desk?
Yeah, it looks like an alien, by the way.
Okay, that's my little fidget toy.
Okay.
You know that black thing is not here. It's a reflection.
Right? Yeah.
But if this was like a really clear phone, like if it was a mirror, and the phone was like all you saw and you
Yeah.
saw the reflection, you might think that it's actually right there.
Yeah, that's true.
That's how I see refraction. I don't know if I'm understanding it right, but it makes sense right now.
Yeah, makes a lot of sense. I like it.
What else, bro?
I'm stoked for his new book. I'm gonna check that out.
That sounded really interesting.
Right?
I can't wait. Yeah.
We have to make sure we put the links on.
I'm gonna definitely hit him up because we didn't even get to the Christian part. Okay.
Yeah.
Because like I said, there's a lot of non-Christians that believe flat earth and it has nothing to do with the Bible. All right.
Yeah.
But then there's a lot of Christians that believe flat earth and they say it has everything to do with the Bible because firmament is in the Bible, circle of the earth is in the Bible, four corners of the earth is in the Bible. You know what I'm saying?
Oh, I got an idea.
See?
Can we watch videos? Sorry to keep interrupting you, Ben. Can we maybe find videos that with like these like learned, teachers out there in the Christian realm that talk about these things? Not like a Greg Locke, but like someone else. I mean, we could find these videos and like do like little snippets and let him respond to them. With those verses, if we can find.
Oh, hold on. You're saying to find Christian pastors who are flat earthists,
And
they're saying their little spiel, and then the same way we
scripture.
did now,
right?
Have him respond.
Yes,
that is a fantastic idea.
Yeah, because they're using scripture, right? And
yes,
and he can come at it with both the both sides of his, because he's also a pastor and he's also knows the Bible,
right?
And
because Christians might be like, "Oh, hey, cool story in math, bro." So the Bible says firmament, and the Bible says circle of the earth, and the Bible says foundations of the earth, and the Bible says. So they don't even care. They don't even care about everything he just said. They don't care about your math. They don't care about refraction. They don't care about lasers hitting the moon. None of that matters to some people because they'll be like the Bible says.
Correct.
You know what I mean?
Yeah. So listen, I was there for. I did the same thing when I thought firmament was actually like from the Hebrew. I was like, okay, well, that's all I need to know. I had so much faith in that word,
right?
That I discredit. And you can figure out, you can make up in your head why that's a lie. So if they're going to tell me about light bending or this is so far away, right? And I can just be like, oh yeah, well, I don't trust that part of it, or I don't trust that part of it, or I don't. You can find out whatever you want. You could twist anything you want to agree with you, right?
Totally.
Whether it's good or bad. In this case, I use the faith. I put my faith in that word firmament to disprove everything else.
Totally.
And I agreed with all these weird videos that were out there because it was simple. I was able to see it with my own eyes. It was a question that I couldn't answer because I don't dig into it, right? So of course it's going to, distort the way I'm thinking. But how crazy is that? How like the devil uses that to cause division, right?
We didn't even get to the division part,
yeah,
bro.
I know. And I think that, in a sense though, Ben, I think that it was probably good that we did the video the way we did with him that hour, because it is definitely like a resource one. It gets it right to the point for the hour. And then we could probably do another video with him. I think he'd come back for that.
I think so too.
And I think it would be a great part too. If you agree and you're listening to this, comment and let us know that that's a great idea so that we can get Dr. Hugh Ross back, especially if you enjoy that, if you're a fan. Because this stuff is not talked about very much in church. And if it is, it's completely like, it's really bad information, right?
Yeah.
Or it's forced, or it's, and they're using their platform to deceive and not tell the whole truth and whatever. So, and it just causes division. So that's why we're here talking about this stuff, you know,
agree.
and I love it. I learned a lot today, and now I got to go back to all my flat earth friends. And,
I can't believe you have flat earth friends.
I have a few actually. They're diehard. And I love them to death, but they're going to probably...
I get it. Listen, I get it. It's just, it's what you see versus what people who are smarter than you tell you. That's it. That's what it boils down to, right? And what's curious is what you see is what people saw 4,000, 5,000, 6,000 years ago.
Right.
And based on what they saw, they came up with certain ideas of cosmology, the shape of the earth, etc. Okay? And now because we see the same things. Things haven't changed over the past 4,000, 5,000 years. Okay.
Right.
We see the same things, and without better equipment, tools, technology, which allow us to understand these things differently, we come to the same conclusions that they came to 4,000, 5,000, 6,000 years ago. We're coming right back to those conclusions. We've regressed back to 1,000-year-old theories. You see what I'm saying? And there's never been, I don't think there's ever been another example anybody could give me where humanity has regressed thousands of years in their understanding of any concept.
Right. And think about just creation itself. So like Darwinism started when, you know, like it's not an ancient theology or
for sure.
Right. It's
evolution,
very, very
Big Bang, none of that.
Yeah, it's all very recent.
Right.
And so we have now regressed to what ancients believed, which was always there's a creator, right?
Right.
And which is really in itself like such a cool thought.
Oh, so you're saying the exact opposite of what I just said? You're saying that we have regressed to that there's a creator or intelligent design?
Yeah, I think so.
But you know why we've done that, Dennis? We've done that because of our tools and experiments and math and physics and everything has shown us that the theory of evolution and Big Bang out of nothing is impossible.
Right.
So they're back to the concept of intelligent design and a beginning to all things.
Yeah.
But
we agree.
But they specify that it's still Big Bang, and they specify intelligent design, not God. You see what I'm saying?
Well, okay, yeah. So they're denying there's a being, a personal being that's behind all this.
Correct.
But they are allowing, which this is interesting, right? They're allowing the opportunity or the possibility for intelligent design outside of God, which would be like an alien kind of being, right? Or
whatever,
right? Extraterrestrial.
They
thing.
literally accept Richard Dawkins,
right?
Who's like the God to all these people, the atheist God. Okay, literally speculates that it's very possible aliens sent alien sperm on crystals to Earth, and that's where life was seeded out of alien sperm. Cool. Yeah. But if I say there's a God that made it, I'm crazy. You know what I mean?
Is that interesting though? Like,
dude, it's such a blindness. It's such a delusion.
That's what
you know
it
what
is.
I'm saying? At least be honest and be like, we're both guessing. Okay. I choose to guess or I choose to put my faith in this guess and this theory because it makes most sense to me and based on human history and blah, 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 blah. You're guessing too. Okay, you have no answers. You're guessing because you're looking at the same things I'm looking at, and you're coming to a different conclusion. You like aliens and sperm. I like God and interdimensional abilities.
Yeah.
You know?
Aliens and sperm.
Alien sperm, bro.
Heard it here on Bennis.
Heard it here first.
Where else?
Where else are you going to hear these things?
So yeah, we definitely have to try to get him back for that. Anything that that you wish you would have asked him that you didn't about this topic in particular that we couldn't get to besides the Bible stuff?
Dude, to be honest, not really. I think the next step was going to be all the Bible stuff, you know, and that's where I'm really, really curious because, like, not to be a douche, but if you're not Christian and you believe this stuff, cool. Like you do whatever you want.
Sure.
My main objective and goal is the Christian worldview and perspective and understanding that further and growing in that. And if this is just a naturalistic thing for you, you know what I mean? Has nothing to do with eternity, salvation, Jesus, none of that.
Yeah.
Good luck. Do whatever you want. Believe whatever you want. I don't care. Affects me zero. Okay. I wanted to get to the Christian stuff, to the Bible stuff. And the reason that this is moving through the Christian community the way it is and causing the havoc it is, I want to deal with that because that does hit closer to home than somebody that doesn't think there's anything else beyond this. I actually think it's kind of like interesting that people who aren't Christian entertain flat earth. Like, why would you deny your masters?
That's a great question. I have no idea.
You have nothing else. The reason you don't believe in a God is because the experts told you there is no God. The reason you believe we came out of nothing is because the experts told you we came out of nothing. Nobody came up with that idea on their own, okay? Except for Darwin, arguably. He had some people that were affecting his ideas as well. But before that, nobody came up with that idea on their own. Everybody believed in a creator. The reason you believe there's nothing else is because people told you so. And so you accepted that as fact. But when they tell you that the earth is shaped a certain way based on, well, this evidence, you're like, no, I don't believe that. I don't see that. You also don't see that there is no God who created life. You don't see that. You just accept it as fact because somebody told you so.
Right.
So how are you the barrier of truth? How do you get to interpret what the experts tell you is true and not true? Because you don't see it?
Yeah. I mean, let's be honest, though. We're talking about one topic. If we ask those same people about different topics, like, creation, they'd probably come up with like some other crazy idea that's not even like based on what, what they were taught or something. They could be pushing back on everything because, again, they're fearing something. And that's where it goes back to distortion. They're just in their own little lost, twisted mind of, because that's where being your own God gets you, right? Like, if you think about that, right? Like, God gave us a choice to obey him or, and follow him and live in his world that he created, or do it ourselves. Yeah. And then doing it ourselves only gets us into like more and more trouble, more and more confusion, more and more despair, like just down the road. And if you're not believing in a God for anything, and you just, then you probably, that's when I say the devil's laughing at those people who are, the truth is right there, but they're just like saying it's a lie.
Yeah.
That's like,
just don't see what ground, if you're not Christian, I understand. If you're Christian and you believe in flat earth, I get it because the Bible told you so. Or at least you're interpreting it to say that the flat earth is flat and that there's a firmament. If you're not Christian, I don't see why you're doubting your experts.
Yeah, it makes no sense.
It makes no sense to me. You know what I mean? So I'm just like...
You're a dummy. You're like the dumbest dumber. The dumbest dumb person.
Oh my God. Wow. That's your opinion. And we're all welcome to have one. This is America.
Yeah, you can't judge me.
So that's the only thing I wish we would have had time to get to was the Christian side,
Yeah. Very cool.
What about you? Anything?
I'm good.
Okay, that's it, bro. Let's get out of here.
All right.
Thank you guys. Love you guys.
Yeah, remember
share stuff.
I guess. Subscribe, comment, tell us, talk to us, join us, send us stuff, and buy our merch. You see that nifty hat behind Ben right there? That's a pretty dope trucker hat back there. Oh, and the beanie. That's just wonderful.
Where's your package?
Go
check your mailbox.
No, it's gonna take too long. Next time they're gonna have to wait. I hope you send me the underwear, and I will model them. You're wearing them, aren't you? Yeah, wearing them. I love it.
I don't think I should show people.
No, please don't. All right, Ben. Thank you so much, man.
We're out.
Have a good one.
Peace.